Yes, good morning all. Can you all hear me? So last class I had stopped the problem between, like, I had not completed the problem, just written the formulas, right? So yes, so I hope you have written this much part, this many parts. That is, what are the things that is given in the question? That is, the first part which is given is the discharge. Discharge for the stream is given. Discharge for the effluent is given. Then the BOD, that is represented as L or Y. We can represent it as L or Y. So BOD of the stream and BOD of the effluent is given, right? Then the velocity of the stream is given. Then DO of the effluent and DO of the stream is given, right? And temperature is given 20 degrees Celsius. At 20 degrees Celsius, the DO of stream is 9.17. So even if they don't give you the DO of the stream, you have to assume it is 9.17 or 9.2 if the temperature is set to be 20 degrees Celsius. Okay. And the T represents the time. And whenever temperature is taken into account, we have to write it as TEMP, temp itself. Temp, as temp itself, you have to write temperature. T represents time. So don't get confused between that two. And KD value and KR value, or K value and R value, are given as 0.13 and 0.3. These are the deoxidation coefficient and reoxidation coefficient. And Stater-Phillips equation, you have written this in the previous class. And finding out D naught, that is oxygen deficit, initial oxygen deficit, and initial BOD. We have to find out. So first thing what you'll do is, if you have written this much, first thing that you have to do is you have to find out the mixed concentration for all. That is, first we'll find out the mixed concentration for the BOD, that is L. L is termed as BOD mix. Mix BOD, or we can take it as actual BOD, or some we can tell it as just a second. Mix BOD or L5 or LT. Fifth day, for fifth day, BOD. What is the BOD value? That is L mix or L5. We can find out. So you remember the formula for the finding out the concentration, right? C is equal to QSCS plus QWCW divided by QS into QW, right? That formula you remember, finding out a proper concentration. So similarly, L5 is equal to LS QS plus LE QE divided by QS plus QE. So write down this formula. For the fifth day, the BOD or mixed BOD or fifth day BOD is equal to this fifth day. It is T. T is nothing but we are considering for fifth day time. For time of fifth day, the mix or BOD mix is equal to LS plus QS. Sorry, LS into QS plus LE into QE divided by QS plus QE. Okay. So what is the answer? Tell me. LS is 4 multiplied by QS is 1.2 plus 0.25 multiplied by 20 divided by 1.2 plus 0.25. Right? So what is the answer? Yes, BOD mix. Tell me. Tell me the answer first. L5 or Y5, whatever you can take. If you're taking it as L, you're considering it as it's L5 or L mix. L mix means BOD mix, mix BOD. Yes, you can use a chat to answer me, reply to me. What is the answer? 6.75 or 76 you'll get, right? Yeah. 6.75 or 76 you can take. That is mg per liter. So it will be in mg per liter. Similarly, you have to find out DO mix or actual DO actual. Similarly, you have to find DO mix and DO actual or DO actual. Both are same. So what is DO mix? We know the formula DOS into QS plus DOE into QE divided by QS plus QE. So find out the concentration. Right? Finding out DO. DO is the concentration we are finding out here. So what is the answer? Tell me the answer. This time I'm not writing down the. Just tell me the answer directly. It is 1.2 multiplied by 9.17. Yeah. Plus 0.25 into 5 divided by 1.2 plus 0.25. Yes. What is the answer? DO mix is 8.45, right? 8.45. 0.45 mg per liter. So BOD mix we got 6.76 and DO mix is 8.5 mg per liter. So two things we have found out now. Now next thing is, once you have done with this DO mix and BOD mix, the next thing what we know is we have to find out L naught. We have to find L naught. And also we have to find oxygen deficit D naught. Not DO, it's D naught. Okay. So D naught is oxygen deficit. DO is dissolved oxygen. So I have explained about this in the starting class. It is a difference between, DO is nothing but difference between saturation DO saturation minus DO actual or DO mix. DO actual or DO mix. Both are same. Right? L naught is equal to LT divided by 1 minus 10 to the power K T, right? This was the formula for finding out L naught. So let us first find out L naught. L naught is equal to LT. LT means, let us consider T as time for T equal to 5. So L5 is 6.76, right? So 6.76 is LT for LT. Then 1 minus 10 to the power minus K, value of K is given 0.13. 0.13, that is deoxygenation constant, 0.13. 0.13 into T. T is 5 for time 5 days. duration that is given 5 days. So answer is 8.69 mg per liter. That is initial BOD. The initial BOD is 8.69. Initial oxygen deficit, that is difference between saturation DO and DO mix, is equal to what? Saturation DO is 9.17 minus DO mix or actual DO we found out here, that is 8.45. That is equal to how much? 0.72 mg per liter. So that is the oxygen deficit. Now you know L naught, you know D naught, you know the time, right? You know the velocity now, right? For now, you know following things, that is this formula we have to apply now. Stater-Phillips equation is there. So we know L naught, V naught, D naught, and duration, that is time required, we have to find out. So time required is nothing but time required we have to find out for 20 kilometers as well as 40 kilometers. So time required for 20 kilometers distance distance is equal to distance by velocity, right? So velocity into time will give you the distance. So our velocity is equal to distance by time. You know this formula. So we have to find out the time for 20 kilometer distance. That is 20 kilometers. So we are converting into meters. That is 10 to the power 3. Velocity is how much? It's given in the question. Velocity of stream is 0.18 meter per second. So 20 into 10 to the power 3 meters into 0.18 meter per second. So you will get time in seconds. Right? So for 20 kilometer distance, the time required for the travel, that is time required for the effluent to travel, is 1.11 into 10 to the power 5 seconds. So you are converting that into days. So divided by 24 into 60 into 60. So it will become in days, that is 1.28 days. So time required for the effluent to travel through the stream for 20 kilometer distance, is 1.2 days. And time required for 40 kilometer distance, that is 40 into 10 to the power 3 divided by 0.18 meter per second, is equal to 2.57 days. 2.57 days. So for 40 kilometer distance we know, and for 20 kilometer distance the time required is 1.2 day and 2.57 days respectively. Now you have to directly substitute in the formula. You have to find out deficit for 20 kilometer distance. Deficit for 20 kilometer distance. So we are considering T, that is time for 20 kilometers. 20 kilometers time means how much? It is 1.28, right? 1.28 days. So D of 1.28 days. 1.28 days you have to find out, and D of 2.57 days. 2.57 days. You have to find out. So tell me the answer now. You have to substitute directly. K value you know, L naught value you know, R value you know, K, okay. Then T value. T is, for the first one, T is 1.28. T value is 1.28 for the first, to find out deficit of 1.28 days. And D naught value also you know. So substitute it and tell me the answer. K is 0.13. 0.13, right? Yeah, 0.13. Into L naught is how much? L naught is 8.69, 8.69, right? L naught is 8.69 divided by 0.13, divided by 0.13 minus, sorry, 0.3 minus 0.13. That is R minus K. 0.3 minus 0.13. Yeah. Then multiplied by 10 to the power minus 0.13 into T. T is 1.28 days. 1.28 days. Minus should be there. Whole minus 10 to the power minus 0.3 into 0.3 into 1.28, right? Plus D naught. D naught value is how much? 0.72. 0.72 multiplied by 10 to the power minus 0.3, that is R. T. T is 1.28. So you'll get the value of D of the oxygen deficit at 1.28 days as 2.08 mg per liter, right? Is it correct? Just check and tell me. 2.08 mg per liter. If so, find the next one. Oxygen deficit at 2.57. Oxygen deficit at 2.57. Tell me the answer. This you have to tell me now. Oxygen deficit at 2.57. Please tell me the answer. Yes, it is 20.7 mg per liter. So you got oxygen deficit. So the problem doesn't end here. So you have to find out the dissolved oxygen at 20 kilometers and dissolved oxygen at 40 kilometer distance. So this is the river, right? So this is the river. It's flowing. So at 20 kilometer, what is the DO? That is dissolved oxygen, not oxygen deficit. You don't want the difference between the saturation and the dissolved oxygen. You want dissolved oxygen which is present. That is not the oxygen deficit. So you have to find the DO of 40 kilometers and 20 kilometers. Right? So now you know the oxygen deficit. You know the formula, right? Oxygen deficit is equal to dissolved oxygen of saturation minus dissolved oxygen of actual. Actual means at that particular area or that particular moment, what is the actual dissolved oxygen? Dissolved oxygen. So you have to find out dissolved oxygen at 20 kilometers and dissolved oxygen at 40 kilometers. So what you're going to do? You have to find out dissolved oxygen at 20 kilometers. That is how many days? That is 1.28 days. 1.28 days you have to find out, and dissolved oxygen at 40 kilometers, that is 2.57 days. That is equal to dissolved oxygen saturation DO minus oxygen deficit. That is saturation DO minus oxygen deficit at 1.28. Oxygen deficit at 1.28 is 2.08. So DO at 20 kilometers or 1.28 days, 20 kilometers or 1.28 days is equal to 9.17 minus 9.17 minus 2.08. That is equal to 7.01 mg per liter. Right? And dissolved oxygen at 40 kilometer distance is equal to 9.17 minus how much? Not 20, it's 2.07. 2.07 that is equal to 7.1 mg per liter. (7.09). So these are the things. This is the answer that you needed at the end. 7.09, 7.1 mg per liter is the final answer. I hope you are clear with this. Anyone, any doubt? Any point you didn't understand? Anywhere you didn't understand anything? Just tell me now. You didn't understand any point. Any place where you felt you didn't understand, you didn't get the solutions, you're not able to get it. Tell me. So first what we have to find is, first you have to find out the concentration, mix concentrations you have to find. That is BOD mix and DO mix you have to find out. Once you have found out DO mix and BOD mix, you have to find out initial deficit, the dissolved means oxygen deficit, and initial BOD. That is L0 and D0 you have to find out. Then you have to find out the time required for 20 kilometer distance travel and time required for 40 kilometer distance travel of the stream along with the effluent. So that is distance by velocity. Velocity is given. So 20 kilometers is the distance. So 20 we have to convert in meters. And we have to find out in days. The time will be in days. Then you have to substitute in the Stater-Phillips equation. This equation you can see here. So in this equation, you have to substitute the values, that is K value, L0 value, all the values are you have found out. You have to substitute that and find out for two different distances. One is for distance at 20 kilometers and distance at 40 kilometers. What is the deficit? So you are finding out oxygen deficit here. Once you have found out the oxygen deficit, you are directly substituting it in the formula for finding out dissolved oxygen. So oxygen deficit is equal to dissolved oxygen of saturation minus dissolved oxygen at that particular point, or actual DO. That actual DO you have to find out. So you know the oxygen deficit at that particular point, and dissolved saturation DO you know. So minus it and you'll get the actual DO. So that's how you find out dissolved oxygen at 20 kilometers and 40 kilometers. Are you clear with this? Are you clear? Please let me know. Are you clear with this? Okay, so we'll move on with the next one more problem. So I want all of you to write down. I want all of you to write down this form problem. So please write down the problem. Using the following data, using the following data, using the following data, find out, using the following data, find out dissolved oxygen, that is DO, find out the DO find out the DO at the end of first day, at the end of first day, at the end of first day, second day, with given following datas, with given following datas, with given following datas. Okay, so using the following data, find out the DO at the end of first day, second day, with the following data. That is, then after writing down the question, draw this table. Flow in meter cube per second, DO in mg per liter, BOD in mg per liter, river, wastewater, wastewater. So flow of river is 25 meter cube per second, wastewater is 2 meter cube per second. Flow means discharge, it is a discharge. DO is 9.1, wastewater DO is 0. So sometimes what happens is, in the question they will not give you a particular DO of wastewater or BOD of river, they might not give you. Okay, so what happens is, if they don't give you that, you are assuming, you can consider it as 0 itself. Normally wastewater DO will be 0 and rivers BOD will be 0 generally. If they don't give you DO of wastewater, you have to consider it at 0 itself. And for BOD of river is not given, you are considering BOD of river as 0 itself, if they are not giving. Okay, just make a note there. In the problem, if they don't give you, in the problem, if they don't give you the BOD of river, take it as 0, and DO of wastewater, take it as 0. Okay, so BOD in this problem it is 2, and wastewater BOD is 200. Take K is equal to 0.1 per day. K is oxidation deoxygenation coefficient, and R is reoxygenation coefficient, that is 0.31 per day. 31 per day. And saturation DO is same. You're considering 9.1 itself as saturation DO. Okay. 9.1 itself we can consider as saturation DO. Generally, they consider saturation DO 9.1 itself. Else they might give you separate saturation DO in the question. They will give you, consider saturation DO as so and so. So DO of river is different, saturation DO is different then. Okay, so don't get confused in that. So now you need to find out. Now tell me following things. First one, you have to find out BOD, that is L. BOD means L. L of fifth day, or T, or actual, sorry, mix. L mix or L of fifth day, or T. Where T is 5. T is 5. L of T you can find out. L of T or L of mix you can find out. You can write, while writing the formula, you can write L of T or L of mix is equal to how much. Then next we have to find out dissolved oxygen, DO mix or DO actual. DO actual is how much you have to find out. So tell me the answer for these two. Yes, it is always L for fifth day. When you are considering L of t, the time duration is always for the fifth day. Whenever you take it, L of t is always for the fifth day. When you find out, okay, are you clear? So whenever you find out L mix or BOD mix, it is always for the fifth day. The t value is 5. It's always for the fifth day you take. Yeah. So what is the answer? Tell me. BOD as well as DO. Tell me the answer of BOD as well as DO. BOD for fifth day. How much? Yes. Any answers? BOD for fifth day is 16 point 16.66 or 67. You can write 16.67, right? 667 something. That is mg per liter. DO mix or DO actual is 8.426 something, 426 mg per liter. So this is the answer you get. Then you have to find out L naught and D naught. It's not DO, it's D naught. You have to find out. Deficit you have to find out. DO mix or DO actual, you know. So finding out D naught is saturation DO sat minus DO actual. L naught is LT or L5 minus, so divided by 1 minus 10 to the power minus K into 5, where T is 5. Once you find out L naught and D naught, once you find out L naught and D naught, you have to find out L naught and D naught. Once you do that, what you have to do is you have to find out what? Time, right? Time is now it's given in the question. So what was the question for you? They didn't give you any velocity or anything. They have directly given you the time. The first day, where time t is equal to day 1, that is 1 day. And the second day, 2 days. Time is 2 days. So 1 day and 2 day. So you have to find out, first you have to find out deficit for day 1 and deficit for day 2. You know the L naught value, D naught value, K value, R value. So all the values what is required in the Slater-Phillips equation, you know. So first you'll find out deficit. After finding out deficit for 1 and 2, then you will find out dissolved oxygen for day 1 and dissolved oxygen for day 2. Dissolved oxygen for day 2, that is saturation DO or DO sat minus D1 DO sat minus D2. So this you have to solve it, this problem. Since you have solved the last problem, I have solved and given you the last problem. It is similar. In the previous problem, they gave you the velocity and distance, like 20 kilometers or 30, 40 kilometers, some distance they gave you. So from that, you got to find out the day, that is duration, time you found out. That is that was 1.28 or something. And you substituted that day in the formula, Slater-Phillips equation. Right? So you have to solve this problem. Next class, when I come, you have to tell me the answer for this one. Okay? Any doubt you have in this, anyone? In solving the problem? Anything you didn't understand? Please tell me. You can text me privately also. if you didn't understand anything. Okay, so we'll end today's session here itself. Yes, Pavitra, can you take the attendance screenshot and send it me?
Yes, sir.
So by next class, one more problem I have that I'll be solving in next class, and we'll finish up with the this module, and we'll start with the next module. If possible, by next class itself, I'll start with the next module. Else, I'll take one more class for solving one more problem, and then we can finish this module. Okay, so we'll end the session for today here itself. Thank you all.